Okay, so in processing, we've mostly been working from the origin, which is represented by 0, 0, and it's mostly up in the left corner. That's a default, but one of the powerful things we can do is actually translate the origin and then rotate around this origin. And this lets us do some nice transformations. Here's an example of translating from the default upper left corner to, 50 pixels in, 50 pixels to the right, 50 pixels. Here I've written a sketch already. It's a 500 by 500 pixel sketch, background of white and a red fill. And what we're going to do is translate the origin from 0, 0 to 50, 50. So it's just 50 pixels in or to the right and 50 pixels down in the positive direction. And then we're going to have to draw a rectangle at the new 0, 0. And you'll see it'll be shifted, and it'll be 100 pixels wide and 50 pixels tall. And you can see here's the resulting sketch. From here, again, translation is all about moving the origin over so we can do more things to it. When we do rotation, we can call the rotate function. One thing to keep in mind is the rotation occurs around the new origin. So if we want to rotate around a point that's not the upper left-hand corner, we'll translate, and then we'll rotate. And when we use the rotate function, it uses radians instead of degree. Now let's add rotation to this. We'll translate it first, and then we'll rotate it. Let's rotate it maybe 45 degrees, which again, rotate takes radians here. So 45 degrees in radians is pi divided by 4. And this should give us a 45-degree rotation of the previous sketch. And here you can see where it once was, going straight across. Now it's rotated at 45 degrees. That's in the clockwise direction. And just to show you, hey, if we wanted to use degrees, we knew what the degrees were, we can always run this function radians on it. And so this will translate the degree number into radians, and that should give us the same result. And here's the proof. Okay, and now that we've gone a little bit further, one of the difficulties of using translations and rotations is that if you have a lot of these translations happening, or if you put it in the draw, these translations can become cumulative and they can add on to each other. And sometimes we just want to move something, translate it, rotate it, and revert back to the original position. So the rest of our code doesn't get affected by that. And one of the techniques we can use is this push matrix, pop matrix. A matrix really is just kind of saving is data around the sort of transformations of a particular state. So push matrix will save the current state of transformations as a reference point, and pop matrix will return to the most recently saved reference point. So it's kind of like leaving a bookmark behind or a marker, and it's like undoing it or going back to it, reverting back to that original state. And so this allows us to get around the problem of too many transformations stacking on each other and getting lost in there. All right, so let's take this existing code and see what would happen if we were trying to draw multiple shapes and using translate and rotation. I'm going to take all this code from here, bring it into the draw. I guess I didn't really need to do that, but I just wanted to set this up. All right. Now the issue is we've already translated this 50 pixels by 50 pixels. And let's say we wanted another rectangle at, at 200 pixels over. Now, if we could translate 200 pixels, let's say 200 by 50. So, we want it to be over to the right. And then we drew a rectangle. What we're going to see is maybe going to be a little bit confusing to us, because here's the result. What happened here? Well, it translated 50 pixels here, rotated it 45 degrees this way, and this rotation is still in place. So from that new origin, it moved it 200 pixels over here, and then 50 pixels down like this. So you can see that movement. Now, that to me, trying to set things on the canvas using this kind of notation would be really hard, because you'd have to keep track of where the origin is and where things are. So a better way to do this is by using push and pop matrix, which again, push matrix kind of saves the previous spot, or saves all the transformations, and allows us to reset or return to it. So we could do all of these, let's see, all of these transformations. And then from here, we'll pop matrix. So this will go back to it. So it's like setting in this case, it'll go back to the most recently saved matrix, which if we go back up to here, at this point, it was the default, which is 0, 0. And it'll take off any translations or transformations. So it'll take away this, and it'll take away the rotate. So this now, when we run this, we'll see a rectangle to the right. And here you can see we went, we did the translation 50, 50, then we rotated 45 degrees, then we reset back to 0, then we translated 200 pixels across and 50 pixels in the y-axis. So that's pretty helpful. And I think where this becomes really helpful is when you have something written in a for loop and you want to leverage the power of that loop. Let's do an example of these rectangles going around the center of the sketch. So let's make a for loop. We'll start at 0. While I is less than, let's say we're going to have 8 of these. We'll add that up. Okay, so let's think about what we need to do. First, we need to translate to the center of the sketch. In this case, we'll do width divided by 2 and height divided by 2. Then we will rotate, and we're going to try to rotate using this I value. I know that I'm going to have 8 divisions, so what I'll do is I'll take 360 degrees. In order for me to evenly rotate around it, I'll take 2 pi, which is 360 degrees in radians, and I'll divide it by the number of divisions I'll have, in this case 8. And then I'll multiply that by I. So this gives me an incremental rotation. So the first time it'll be 0, the next time it'll be 2 pi divided by 8, the next time it'll be 2 pi divided by 8 times 2, and so on and so forth. So let's see what happens when we put our rectangle here. Now, I'll start it at 0 and 0, and then we'll kind of change it around. Maybe we'll make it 200 by 20, so it'll be a little bit skinnier than what we had before. And let me just clean that code up, and let's run that and see what happens. You can see the first one went fine, and then it got out of whack because we weren't pushing and popping the matrix or returning. So what I want to do here is, in this case, I don't want to keep translating. I only want this to happen, once for each time I draw it. So I'll put the push matrix here. This is going to save the transformations, and in this case, it'll kind of go back to the default. It'll do all these things, and after it draws it, then we'll pop the matrix back so that it gets reset, and then these transformations don't add on, they don't become cumulative. And let's take a look at what that does. And there we go. We have now the transformations applied, then the rectangle is drawn, then it's reset, and then it's applied again, and you can see this incremental rotation will help move that over. So this is a good example of this kind of centrally focused composition. Now, one question might be, what if you want some space in between here? I think there's a few ways that you could approach that. Let's see. One way is by adding a value to here. I think let's try this first. Let's try putting 100 in the x axis, and what does that do? Okay, so that in that case, what it does is it translates it to the center. It rotates it 0 degrees, which would be this way, and then it pushes over 100 pixels that way. So that's one way that you could do it. Another way you could do it is you could write another translation here. You could translate this way. That 100-degree shift, you could put it in a separate translation. Well, actually, sorry, you shouldn't do that. That would be weird. I think you actually put that in here. There you go. So sorry, the order of these things matters. So you translate to the center, you rotate, and then you push it out. So I did that in the wrong order, but I'm kind of glad I did so that you could see what happened. Again, because we're not in center mode, these aren't perfectly centered, but if you wanted them centered, you could change the rect mode to center, or you could just offset your rectangle. But this should produce, oh, there we go, a centered rectangle, and you can see these things line up this way. Another good thing to learn is how to use shapes and um, incorporate them into our sketches. We're going to use shapes and rotate them on the screen. Um, in order to do this, we'll need the data type PShape. This can store shapes. There's I guess, two ways to approach this. One is to actually create a shape. Um, we'll using begin shape and end shape and creating vertexes, and we can draw those things algorithmically. Or if you have another program like Adobe Illustrator or some vector-based program, you can create SVGs or scalable vector graphics. And if you put those files in the data folder of your sketch, you can actually access those by using load shape. Okay, so here is an example of that. Okay, so let's go over how to get an SVG file out of Illustrator and bring it into processing. Here I am in Illustrator, and I have this shape. This is actually a wingding. So it's type right now, and I need to outline it first. So I'll just convert it to outlines. I'm maybe I want to just center this for ease of use later. But okay, so here's my shape. Okay, and so what I want to do is export this as an SVG, and I want to bring this into my data folder of my sketch. I started a sketch here. So what you'll need to do is have a folder called data, and it should be lowercase. And then here we'll just I'll name this maybe shape. And yeah, we'll just save that out using the default is fine. So when I move into processing, I should be able to access that. Okay, so here's the sketch that I created. You can see it's just a 600 by 600 pixel um, sketch. And what I want to do is declare my variable, my shape variable, PShape, and I'll call it S. And inside the setup, I'm going to want to load the shape file. The way that I'll do that is by calling the load function or the load shape function, load shape. And the file that I created was called shape.svg, so I want to put that inside of quotes. And again, this only works if you have something in the data folder. A quick shortcut is Command K, and you should be able to see your data folder here, and it's the shape SVG. Okay, so from there, we are going, in order to draw this, inside of the draw, let's just make sure it's working. We'll call the shape function. Now, it's going to ask for the parameters, what shape, what's the name of the shape. We'll feed it the variable S, and then we'll give it, I'll do a mouse X and mouse Y for right now. Just so you can see this, I am going to place it where the mouse cursor is. So that's going to give us, whoops, there we go. So there, looks like that shape came out a little bit weird. Okay, but at least you can see how to load up a shape. Okay, so I just made a quick adjustment to the shape. I think the reason that was happening was there were some overlapping paths or something. So I just used Pathfinder to cut out the paths. That's something you might encounter if you have a complex or overlapping shape. So here we go. We fixed that there. Let me just do some other things here. I want to change the color of this. Now you would think if I change the color, let's say to red, I could just run the fill and it would apply to it. But when we do that, you'll see that it's not changing. And that's because it's taking the original styling from the file. So in order for us to change the style, what we'll want to do is disable the style on this shape. So we can just go up into here and say disable style. And once that happens, all this code should run. We should be able to change the color. And again, there's some weird things happening here where I'll probably need to go in and cut my shape out even more. But we can start with this as a form. What might be fun now is to just do a centrally organized composition like we did before. Let's say it's we'll use a for loop here. Maybe we'll say it's 10 pieces. 10 rotations, and we'll use, so just to practice, we'll do a push matrix to save this, the transformations. We'll translate this to the center. And then we'll rotate it. Now we'll take 360 degrees, or one full rotation, divided by 10 in this case, because we have 10 segments. And times I. And instead of mouse X and mouse Y, let's just do 0 and 0. What does that look like? And lastly is pot matrix. Let's clean that code up. And here's the end result of that. One other thing I might show, since we're working with a sort of central composition, is we can change the color mode on this to give us 360 degrees of color. There's something, the color mode HSB, or hue, saturation, brightness. We can set that up here, and we'll set how many degrees on the hue we want to go over. In this case, 360. Saturation we'll set to the max is 100, and brightness is 100. That will give us really saturated colors. And then what we could do down here is, instead of using this fill, we could try to set the fill according to these degrees of color. I believe what we could just do is, so now that we've changed the mode to HSB, it's going to accept values that go up to 0 to 360, 0 to 100, and 0 to 100. So it changes the mode. But what I want to do is maybe take 360 divided by, in this case again, 10 times I. 360 divided by 10, because that's 360 degrees divided by the number of rotations, times I. That's going to increment things. And then maybe to keep everything really saturated, I'll say 100 and 100, saturation and brightness. And if I do it this way, I should get a kind of rainbow-like coloring that occurs along the color wheel. Yeah, so this is something that we can play with since we're going in 360. The other thing you might want to try is changing maybe the blend mode. So we can change different blend modes, and you could try something like multiply. And let's see what that looks like. Here you can see the colors being multiplied. I should also say, because we changed the color mode, this background 255 no longer works. It's no longer white. What you would need to do is, it's basically, it could be any hue. Maybe we'll just say 0, but it's no saturation. So HSB, hue, saturation, brightness, and we'll say 100 brightness. That should give us a white background. And there you go. So you can see the end result. So these are some techniques of using P-shapes, and also coloring things using different color modes, maybe playing around with blend modes. And you can look up the different blend modes that exist. There's multiply, screen, exclusion. There's a few, so you can take a look at those. Let's just do one more while we're here. Let's see if this one works. Yeah, there you go. That's exclusion. So there's some interesting effects you can have here. I'm going to keep going with this, and now try to get this to move a little bit. Right now, it's kind of a static composition. So a few things I could do here. Maybe I'll have an angle variable here, float theta, and just to get things to rotate more, I could add theta to the rotation here, and outside of the for loop, just want to increment theta plus maybe something small. So let's run that, and let's see what that does. If we do something like that, you can see it's rotating. It's probably rotating a little bit too slowly. So just make your theta increment a little bit bigger. And that's what that looks like. So that's moving. Another thing you might want to try to do is have the pieces move apart. What we could do is, instead of just 0, we could even take sine of theta times some sort of sizer here, or maybe I'll just say 200 for right now. Whoops. That's just so that it's greater than -1 or 1. Okay, so sine plus theta. So that's going to push things out. So let's see what that does to it. Okay, and now it's moving out and it's moving back in. So we're using the sine wave to kind of control it. That's kind of fun. One other thing you might want to try is offsetting it. So right now it's happening at the same rate for all of these, but if you added like plus I, that would offset things, or let's say plus I times, maybe like some sort of angle with an offset, maybe pi divided by 32 or something like that. So we're trying to do like something that would offset things. Maybe that's too small, but you can see that they're at least going at different rates. I think if we did something like pi divided by 8, we'd get a different effect too. So again, I just like playing with the math sometimes. Yeah. One last thing I want to show about the shape is that you can also reset the size. In this case, I rewrote this. I started using a tangent function instead, just to give you an idea. And I can change the size of it to 50 pixels by 50 pixels, or you can run some math on this. It could be fun. I made some other changes here where I added more elements, but just to show you what that looks like. Don't feel like you are stuck with the size that you made your SVG. You can always change it in the code. The last thing we'll talk about is using 3D mode. So we've mostly been using 2 dimensions, X and Y, but we can also access the Z dimension, the depth. Processing has a 3D mode that you can access just by adding this parameter into your size. So do the width and the height, and follow it up by P3D. That's going to turn on the 3D mode. Within this, also, we can specify different axes to rotate around or translate. Or when we use translate, we can use 3 dimensions, not just X and Y, but X, Y, Z. So again, here are the different axes you can rotate around, and as you do this, just keep in mind to use radians instead of degrees, or that any values you put into here will be calculated as radians.
Okay, so a good assignment to practice now all these techniques is maybe something similar to what we created earlier, a sort of centrally focused composition, animated composition. I think this will allow us to try all these different techniques out. I'm going to do an example that uses P3D so that we're practicing that as well. And I'll also try to write this using a class and an array, so we'll have multiple copies, but I'll incorporate the push matrix, pop matrix, and hopefully you'll see, in a situation like this where we have, classes, objects, and arrays going, if these transformations were stacking, it would be just really insane. Let's try just, again, setting up a P3D sketch, processing 3D. All you do is you go to size and you write P3D as the third parameter, just like that, and we'll set up our draw, but I'm gonna think about what I want to make next. So the thing that I want to make is something like this. You can see it's a series of cubes rotating around in 3D space, and the color is like on a spectrum, sort of a rainbow spectrum. So I'm going to change the color mode here. Yeah, so let's go ahead and try to code this. Okay, so now I'm going to start by writing the class, writing that object for just one rotating spinning cube. Let me call it cube rotate. And I'm going to just start by writing this out. Again, I think this practice is important. Let's see, so there's the class. Let's think about the variables I'm going to need. Float x, float y. Because we're in 3D, we need a z variable, and we'll need some sort of sizer. Let's try that out. Whoops. We're going to have a little bit of an offset here from, I believe it's from the center. Theta is going to calculate the angle, so anytime we're doing rotation, it's good to have some sort of variable for that. Let's have a variable for increment as well. And I'm gonna throw a float t here. I may use some noise, and so having another variable to change the noise might be a good thing to have. Okay, so let's set up our constructor here. So I just need to create all these: temp x, float temp y, float temp z, float temp sizer, temp theta, temp t. I think that's all. And then inside of here, I'm just going to pass the variables again. And I will write this as a, whoops, t is equal to temp t. Whoops. I just want to make sure that it's case sensitive, it matches up. Okay, great. All right, so outside of that, I'm going to write my methods here. What are the functions I'm going to call? And I'm just going to write one, run. Okay, so we need to do some translations here. We're going to use the push matrix to kind of save the original spot, and we're going to always pop back to it or revert to it to avoid stacking. So we'll translate it x, y, z. Especially in 3D, it's important that we do translation because some of the functions like box, which is we're gonna use for the cube, or sphere, they don't actually take x, y, z coordinates, so we actually have to do translations in order to move them anywhere. Okay, so let's translate the center point. I don't need to put a semicolon there, but force of habit, rotate it. Now we can rotate it along different axes again. Now when we just do a rotate, if you look at the example, there is rotation across different axes. So you could have rotate X, rotate Y, and I believe that rotate, if you just leave it as rotate, I think it's rotate Z, or what we're used to seeing. So here, what I'm going to do is translate again. I mentioned that I want this to be offset from the center, so I'll put the offset in there. Okay, move from the center. Now I could put a stroke on here. I'll just do it for now. Or you could turn no stroke if you don't want to see that at all. Let's just try to put a fill here for right now. Maybe I'll just say 100, 100, 100. I'm going to go in and change that later. I just want to set this up. Okay, so we're going to use the function box, and if you give it multiple parameters, you can make it more skinny or wide. If you just give it one, it will draw a cube. Okay, so that drew everything down, and then after the transformations, we want a pop matrix, so go back to the original state. Let's put on the increment. Theta plus equals increment here, and we're not using noise right now, but if we do use noise in the future, I might want to put an increment for the noise. Okay, and actually, I'm sorry, we're not even using theta right now. Actually, we are using theta in the rotation, but I'm going to use it later on for color, kind of jumping ahead a little bit. But okay, so let's try writing creating an array. We'll use the class cubeRotate. Let's make an array called cubeArray is equal to new cubeRotate. why don't we just try 20 for right now? We can always change that. Earlier I mentioned I want to use this kind of rainbow colored color scheme, so I'm going to set it to HSB color mode, 360 for the number of degrees of color, 100 for the level of saturation, and 100 for brightness. Background, then if you wanted this to be white, it could, or black rather, saturation is 0, maybe the brightness is really low, maybe it's 10 or 0 would be completely black. Now let's initialize the arrays. So we'll grab this cube array.length so that if we change the length again, it will automatically update. From here, we're going to write cube array I is equal to new cube rotate. Here we want to feed in the values in this order. So we're moving it to the center, that's width divided by 2, height divided by 2, x, y, and the z. We can just leave it at 0, but you could update that. The next one is going to be the sizer, offset. Okay, so maybe what we'll do is start to offset these based on where these cubes are in the position of the array. So maybe we'll start with we're gonna map this out for the sizer. We'll use I, and the minimum of that is cube array 0, and then the max is cube.length, or about the max is about that. And maybe we want to remap the values. Let's try 10 to 50 for right now. Okay, the next one is, I believe, is the offset. So we'll do a similar map. And hopefully you're seeing like mapping I is like a really helpful way to get some sort of sequence going, or some gradation. Let's do cube array.length, and maybe for this, this is the offset. So we want this to be a little bit bigger of a range. It goes out a little bit further, let's say to 350. Okay, as far as data goes, we can feed it. We want to feed it different values here. Let's take pi divided by 4 times I, or it could be something else, or you could, if you wanted to be, if you want it to be evenly distributed, you could do 2 pi divided by the array length times I. That's something that we did earlier. And then I think the last part is the increment. So one thing we're going to do is make it move faster in certain areas. So again, we'll use map of I 0 cube array dot length, and let's say it goes from really slow to like a little bit faster. And then I think the last value was t, which maybe I'll just throw in a random value, random one. I think that's okay to put there. And let's just keep going. We're going to go to draw now. Oh, I have the background here anyways. I mean, I guess I could just put this here. It might be a little bit simpler. Let's make that 0. And then we need to run the array. So we'll grab for loop again, cube array I, and let's see, dot run, and parentheses because it's a function. Let's just see if that works, if we got things running. Okay, so you can see we sort of got this moving. The rotate is rotating around here, and then you can also see the cubes themselves are rotating along the y-axis. So you get this kind of interesting motion. Sometimes they start to line up, and again, the nice thing is I could change this number really easily to 100, and it should just change everything. Yeah, there we go. So we got a lot more, and you might want to play with this, like the speed or other things. Okay, so I put, all right, so I put this color here. I'm not doing the rainbow thing that I wanted to do, so let's see how we might achieve that. One thing we could do is, we could fill it with, we could have it be affected by the theta somehow. We could have it be affected by I. That could be an interesting thing. I'll actually do kind of like a sine wave. So I'll actually do kind of like a sine wave modulation here. What I'll do is, I need the values to be between 0 and 360. So what I could do is use an absolute value function. That's what this is. And I could do something like sine of theta, right? And I could do times 360, so that, if it ever went to a negative number, it would return the positive number. That's what absolute value is. And I think that's one thing I could try. Let's just do that 100, and then for the brightness, maybe we'll try it with 100 as well. So this is hue, saturation, and brightness. Let's see if that runs a rainbow. Like, there we go. Oh, that's a little bit crazy, but yeah, I guess it's kind of working. This is kind of like an oscillating rainbow, so that's kind of fun. If I'm looking at this, I might think that it's going a little bit too fast. So maybe 0.05 is too much. Maybe it's like point. I wonder if I did it like this. I'm resetting the theta increment here, so it should move, yeah, a lot slower. Yeah, that's kind of interesting, I think, on its own. And I guess just to show you, let's say I wanted it to be controlled by like the I value. Well, we could feed in just the value I, or we could use something. If I know this thing goes from 10 to 50, and that is the size. I believe that's the size. I think I could probably map this out. I could take like map sizer. I think I could do something like this: 10 to 50. Remap it to 0 to 360. So there you go. So you can see now I've remapped the color according to the size. So here it's kind of this reddish pinkish, and then it goes out, and then it hits the end of the 360 part. So there's other ways that I could color this using some variables. But again, this is a good exercise to concentrate on. Can you make your own centrally composed animated graphic? And it could be in 3D or it could be in 2D. You could use PShape if you wanted to, but it's a good challenge. Okay, and real quick, I forgot. I mentioned I might try to throw some noise in here. What if I wanted to put some noise in the saturation? So maybe it becomes more or less saturated. I could run it. I could throw in noise. The noise function, we're going to throw in T. Again, noise goes from 0 to 1, so we need to multiply it by something. So maybe we'll say 100 minus noise times 50. And that should give us a little bit of variation. And it's also really important that you're incrementing that T, so you're seeing some change, just like theta. Let's see what happens when we run that. We should get a little bit of movement. Yeah, you can see that the cubes are kind of like changing their saturation a little bit. Maybe just to get a little bit more. I just want to show you, I'm going to turn up the noise a little bit, just so you can see that it's actually doing that. I swear it is. Yeah, there you go. You can see the noise is working, and that's probably too much noise, but I just wanted to show you that.